Corporate Finance Excel Practice Problem. Future value with uneven investments. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in our Excel worksheet. If you're following along in the Excel worksheet, we're in the Practice tab as opposed to the Example tab. The Example tab will have the example to it, basically the answer key. Our scenario is going to be a future value uneven investments. Note, when we're thinking about the present value and future value, you could break them down into some basic kind of scenarios. One, are we doing a future value calculation? Are we doing a present value calculation? And then whether we're doing present or future value, then are we talking about present or future value of one or present or future value of an annuity? You can kind of see that in terms of the tables as well when using the tables for these calculations. We typically have those different tables that will be used. But then you might say, well, what if we don't have even type of payments that are going on? Whether we're doing present value calculations or future value calculations, if we don't have an even set of circumstances, then we cannot simply jump from, say, a calculation of one to an annuity because we don't have that standardized kind of setup. So we have to do something else. What are we going to do? Exactly what you would think what we would do. We're going to have to break up the calculation into components for the uneven kind of things that don't fall into what we would like to nicely see. So, for example, if we were to put money in like an annuity type of situation, but we have one situation where we're going to have an increased amount of payments over time and we think the rate's going to change, then we could use the present or future value calculations depending on the circumstance of the practice problem of one for each period involved, which is the more tedious way to do it, or if we can break certain components out into an annuity and then apply the annuity out and then break out the different scenarios, we can do it in that format. Some combination of present value or future value type of calculations to accommodate the problem. So let's take a look at this one. We have the original investment of $14,000. So we're just going to put a one-time investment in of the $14,000, not an annuity. The years are 10, and we think the percent is going to be that 11%. Then, at the end of that 10-year time period, we believe we can take that, whatever the amount is, put it back in place and get a return of the 15%. So we've got this two components, two types of investments. One is known, the 14. Then whatever we have at the end of that time period, we're going to take and we're going to put it back in place for another 12 years. So we don't know what the amount is until we do the first calculation. And we're going to have a different interest rate of the 15%. So we're basically doing a future value calculation, which is just not an annuity here. We're taking the present value times 1 plus r to the n. Let's do this in a couple different scenarios as we've seen in the past, starting off with the mathematical equation. So we'll do the mathematical equation for the first one, and then follow it with the second one. We're taking this equation, breaking it out into like a table format. I want this times this in the outer column, and then I'm going to pull this 1 plus r to the n in the inner column. So let's do that. I'm going to say in the outer column, I'm going to take the 14. 14 is the original investment. Then I'm taking the 1 plus r to the power of n, which is going to be the 1 plus the rate is 12 or 11%. Percentifying that by going to the Home tab, Numbers, Percentify, underline, Home tab, Font, underline. Summing this up equals the sum of these two items. Percentifying that, Home tab, Number, Percentify, to the power of the number of years or periods, in this case that being in the format of years rather than months. 10 years, 10 periods. Then if we do that calculation, 110% to the power of, which is shift 6, the caret 10. That's going to give us this number. Let's go ahead and add some decimals. Home tab, Number, decimals, so we have a more complete or accurate number. And then that is going to be the amount, which I would like to have actually in the outer column. Let's do that again. I'm going to delete this. I'm going to pull it out here because that's going to be the full second part of the calculation. Then I want to multiply these two together in the outer column. So I'm going to take that 111%, shift 6, caret times 10, number of periods, n. In other words, add some decimals, Home tab, Numbers, decimals added. Let's put an underline 2, Home tab, Font, underline. And then we'll do the calculation. We're now at these two amounts that we can multiply out, this being equal to the 14,000 times that number that we just calculated. Add a couple decimals there, Home tab, Numbers, add a couple decimals there too. Then we're going to go down and do the same calculation down here because now we know the starting point, which is going to be this number, which we'll use for this second component, which is going to be, we're going to put that in place for another 12 years, but it's going to be making 15% this time. So we're not going to touch it for this whole time period. So we're going to say this is going to then be equal to the 39,751 at that point in time, at that present value. So when I'm saying present value, it's the present value as of then. And then we could add some decimals, home tab, numbers, a couple decimals up top. So that's going to be this one. I'm doing the same calculation, 1 plus r to the n, 1 plus r to the n. This is going to be 1 r 15%, which we will then percentify by going to the home tab, numbers, percentify, underline, home tab, font, underline, adding them up with the trusty sum function equals the sum of these two items. Percentifying that one, home tab, numbers, percentify. Then we're going to take it to the periods, the number n, the number of periods, in this case in years instead of months. Be careful there. 12 years, underlining it, home tab, font group, underline. Let's pull this out into the outer column. So this whole second component now in the outer column is going to be this 115 to the power of, which is shift, caret, 12. Let's go ahead and add some decimals there. Home tab, numbers, adding some decimals. Underline it, home tab, font group, underline. Final calculation, the PV times this thing we just calculated here. The PV times this thing. Add a couple decimals, home tab, number, couple decimals. So now at the end of this whole thing, we're at the 212, 680, 257. That's the long way of doing it. Now let's do it with like tables so we can kind of see what would happen from period to period, which is complex to do mathematically, you know, if you didn't have Excel, but like we have Excel, so it's easy. So I'm going to say this is going to be period 0 starting this time, 1. Then I'm going to select those two, autofill it on down, putting my cursor on the autofill handle, dragging it down, auto drives it down, Dr. Phil does the calculations. Then we're going to go to the home tab, alignment, let's center those. And then we're going to start with the value of the 14,000. Now there's not going to be any other investments. That's just going to be where it's at. Let's just run a table as interest accumulates period by period, year by year in this case. Let's take that 14,000 times the 11% and then add this up. We had 14,000 before. Now we got another 1540. Let's do it again. Now we got the 15,540 times the 11%, and it's growing. It's growing. Interest is growing. Look at that. That's neat. So we got that plus that. Let's do it again one more time. Then we'll use the autofill. This is going to be the 17,249 times the 11%. And last time we had 17,249. Now we got the 1897. These are estimates because they are rounded. There we have that. What if I was to autofill it down? Could I copy that down? It's going to have a problem with it. I'll let you know right now, but let's just copy it down to see what that problem will be. Copying it down using the autofill. This one turned into 0. That's not what I expect. Interest shouldn't be 0. Why? Because if I double click on it, it moved this cell down. Don't want it to do that. We want it to stay the same. Going to use the absolute references to tell Excel not to move it down. Don't move it down, Excel. So I'm going to select these two and remove it. Double click on this one and fix it with an absolute reference is how I'm going to fix it. So we're on B4, that B4, don't want that one to move when we drag it down using the fill handle. So I'm going to put my cursor in there and select F4, put in a $sign before the B and the 4, telling Excel don't move it down with an absolute reference. That's what an absolute reference is. You only need a mixed reference, by the way, for picky people out there. But absolute reference works, and I don't have to think too hard about like which one needs a $sign and whatnot, which you probably want to practice doing in any case, but I don't want it right now. So I'm going to go ahead and then autofill it down. Autofill, there we have it. And then if we select these ones, let's add some decimals. Go into the home tab up top and then the numbers and just add a couple decimals there. So now we'll do the second one, same kind of thing down here. Now we got 12 years now, but we're going to take this ending number, which matches what we got there, and then do the same thing here. So I'm going to say 0 down to 12, 0, 1, and then I'll copy that with the good old autofill fill handle, dragging on down to 12 years. Let's go ahead and center that, home tab, alignment, and center it. We're going to start off at period 0 where we ended last time, but now we're going to calculate the interest at that amount times the new rate, which is 15%, totally different rate. So now if we add this up, this is going to be the prior number plus the new interest. And then we'll just continue on in this way. This is going to be equal to the 45,715 about times now the 15%. And then this is like the prior one plus what we did there. Let's do it one more time. This is now the new number, 52,572 times the new rate, 15%, adding then the 52,572 plus the 7,886. If we autofill that down one time, we see we're going to have a problem again. This one doesn't look right. Why? Because it moved that cell down. So I don't want it to do that. So I'm going to use my absolute reference again. So I'll delete this one, double click on this one. That cell E15, is it? E15 needs to be absolutized. So I'm going to put my cursor in E15 and put F4 $ before the E and the 15, absolutizing it. And then hit enter, and this time I'm going to select these two. I'm going to autofill it all the way down. I'm not even going to check it because that's the carefree person I am. I'm just going to autofill it all the way down, and there it is. There's the 212,683. Let's add some decimals here. So I'm going to select this column, Home tab, numbers, add a couple decimals. There we have it, matching out perfectly. Let's do it a different way. Let's say, well, what if we did it the easy way? Why are we doing this complicated stuff? Let's just use the formula for the future value. We'd have to do this 2 times again, same kind of process. This equals the future value of the first one. Future value where we started is going to be the rate. I'm just going to pick it up here as the 11%. That's for each year because the periods are in years, times the number of periods, which we said was 10. Let's pick that up over here, 10 periods. Comma, we don't have a payment because we use that for an annuity, and this isn't an annuity, so I'm just going to enter another comma, and then the present value, which is that 14,000. I'll pick that up here and enter. There we have it. There's our first half again. Let's make it a positive number by double-clicking on it, putting a negative before the F, flipping the sign. Then we can do the second half here by saying this same formula, but now with that number as like the starting point, and then the new rate, which is 15%. So this is going to equal the future value once again, but now starting with the rate of 15%, comma, number of periods is now 12 periods from our second calculation, comma, it's still not an annuity, so you could put 0 or 2 commas. I'll put 0 this time because I did 2 commas last time. And then we have the present value, which is this number. Notice I am picking this up from the prior calculation. If you have rounding, which we do here, it'll be slightly different if you cut it out to just 89 as the 2 decimal places. So just keep rounding in mind all the time. Rounding in mind all the time. I'm going to then double click on this one, put a negative before the F, and there's the 212,682.57, which I think is the same as that number if I remember correctly. So once again, we have calculated it properly, but differently, but still proper. So let's do it again with the tables. So we're going to start with the 14 on the table time. Let's do the table time this time, and that's going to be the 14, 10 periods, 11%. So 11%, 10 periods is going to be 2.8394, 2.8394, 2.8394, 2.8394, 2.8394. 2.8394, multiplying it. Well, let's add some decimals. Home tab, number, 4 decimals, underline, home tab, font, underline, multiply equals 14,000 times that number we just put there. Add a couple decimals there, home tab, number, decimals. 39,751.60, a little bit different, but close, because of rounding due to the fact that they only took it into 4 places out. Let's do now the second half, which is going to be that 39,751. Let's add a couple decimals to it. Home tab, number, decimals. Then we've got a table for the table time for the second one. Second one, table time. 12 periods, 15%. So 15% is over here. 12 periods, 15%. 12 periods is right there. That's 5.3503, 5.3503, 5.3503, 5.3503, 5.3503, 5.3503. add decimals, home tab, number, add a couple decimals, underline, home tab font, underline, multiply, this equals the 39,751.60 times the 5.3503, add a couple decimals, home tab, numbers, adding a couple decimals here. There we have it. Not quite the same as the number over here. We had two rounding issues because we had two separate calculations, taking it out to 4 digits, cutting it off at 4 digits. So if you do that a lot, it could start to be a little bit different of a number because of rounding, but probably not significant for normal decision-making purposes when you're talking about this level of number. But they could use that in book problems to differentiate what the calculation would be if they want to force you to use either tables or some other type of method. So note, you can imagine many different scenarios where the payments are not in unison. You don't have a payment of 1, you don't have a payment of an annuity. You can imagine it for present value types of problems, future value types of problems. What you could do is, of course, break everything down to basically, present value calculations of 1 for each period, which is tedious, but not all that difficult to do for if you have like Excel, to do that. It's really not that hard. Or to do it as efficiently as possible, you can break down whatever fits into an annuity calculation into an annuity calculation and then pull out the components that don't. We have to do some combination of present value, future value. We can always use the present or future value of 1, but it can be tedious, and then we can shorten up what we're doing by using the annuity calculations where they're applicable.